There, just wanted to give a simple explanation for the Log4j vulnerability that's in the news these days for non-technical people. So because this vulnerability is in Java, I'll have to take a step back and explain, how a modern software development works, especially languages such as Java and C Sharp, etc. So let's say if you want to build a e-commerce application, and let's say if you have chosen Java as a language in which you want to write that your application. Now you would not write everything from scratch, from the payment gateway to user interface to a shopping cart, etc. Search bar. You would not write all these functionalities from scratch. What you would do is that you would already make use of components that other Java experts have already written, and you would just integrate those components in your application for different functionalities that you want. Similarly, Log4j is a jar file in Java which gives an application logging capability. So let's say if you have to make use of logging, and why would you need logging? Let's say if you want to log information in terms of who are the guys visiting your website and doing some things, maybe not making a purchase, etc., and just going back. Certain logging functionality, I'm not sure exactly what, but certain logging functionality Log4j is able to provide your application. Second thing that we need to understand is that this vulnerability is on the server side. To understand that, we'll just have to take a step back and understand what's client and what's server. Let's say if you want to visit amazon.com, you go to your favorite browser Chrome, you enter amazon.com, you hit enter, and it fetches for you the result for amazon.com. That's displayed to you and you do your shopping. What's happening over there is that Chrome is basically your client, which is installed locally on your machine. And on the client, when you enter amazon.com, that request goes through the network, the internet network, the internet actually, and it goes and hits one of the Amazon servers from which the result is fetched as per the user query entered on the client side, and that response travels all the way back across the internet. Then it comes to your computer, and it hits that port 80 here, because port 80 is the one configured to listening for HTTP connections, and that information enters through port 80 and comes to your Chrome application. And then Chrome browser has that ability to be able to make sense of that zeros and ones, that information packets coming in, and to be able to display that information in a human readable format on your Chrome browser. So that's how the client server architecture works. I mean, that's a very simple explanation. So there is actually a risk here. If in case there is a very special query that on the user side, on the client side, somebody is entering to fetch result, let's say credit card information, etc., and if servers on the backend of amazon.com are not well equipped to deal with that user query coming in, what then can happen is that information leakage can happen. So the front end can then start to get information from the backend that the business never intended for the backend to send to the front end. So therefore there's a control called as data input validation that needs to be in place, in the sense that whenever a user request come in from the front end, then the backend server should have functionalities to process that, and to be able to process only legitimate queries. Illegitimate queries, any kind of hackers input queries, search strings, should not be processed by the backend, otherwise that can lead to information leakage. So that brings us to the topic of secure coding practices. So software developers who are writing the backend of these applications have to follow secure coding practices, which include putting in proper data input validation controls in place on the server side, so that only legitimate queries are processed, and any illegitimate queries, the kind of queries coming from a hacker, are just discarded. They're not processed by the backend server. So what's happening over here is that Log4j is actually a vulnerable piece of code that's actually processing illegitimate queries, that's especially crafted queries coming in from the front end. And then what's then happening is that it can lead to any kind of information leakage, ransomware, any other kinds of attacks. Now, the reason why Log4j specifically is making such big amount of news is for three reasons. So there's a multiplier effect over here. See, first of all, Java is extensively used in enterprise-wide applications. Second thing is that Log4j is very popular logging library that's used extensively in Java application. And the third thing is that the skill level required to create that specially crafted query on the front end to for the log4j jar file on the backend to throw up results that the business never wanted it to throw up, that skill level required to create that special string is actually very low. So therefore based on these three conditions, it's having a multiplier effect. Now, another thing that requires clarifications, what are the kind of assets which are under threat? Because on your network there can be CCTV cameras, they could be servers, laptops, printers, etc. See, generally servers are the one which are under impact in this particular vulnerability. Servers who are on the backend using Java, and when they're using Java, they are using the vulnerable version of the log4j file. Generally, other components would not be impacted. Generally, and especially if you have a scanning software which is looking and finding log4j on laptops, that very likely is a false flag. Now the reason is because, see, log4j file on your asset is a necessary condition, it's not a sufficient condition. See, there has to be an application up and running on a certain port, listening on a certain port. So if there is an application code base on somebody's laptop, and but that application is not up and running, it's not listening on a pertain on a certain port and listening for incoming connection, then it's not a vulnerability really, because log4j file has to be present on the server backend, but that, you see, that application also has to be up and running for it to interact with the internet, for it to for the log4j file to process user inputs, and for it to then misbehave and throw out certain results that the business never wanted it to throw out. But having said that, there could be cases where certain developer is running a Java application which is up and running and facing the internet. So that could actually be a vulnerability. Okay. So how quickly can this log4j vulnerability be fixed once it's been identified on your servers? So the guys who maintain this open source library called Log4j have already released the latest safe version that's called 2.17. And what your Java developer would have to do is just have one line of code chain. They would just have to, instead of using 2.x, they would have to use 2.17. Of course, they would have to do certain amount of testing as well to make sure that the rest of the application works and it is compatible with 2.17. But in terms of coding itself, just requires one line of code chain. Unless, of course, if it breaks the application, then you have to see what components are breaking. That might require more time, but generally in these kinds of cases, one line of code change in most cases should be enough for you to upgrade to the safe version. So I hope this was a simple enough explanation for the log4j vulnerability. Please do let me know if there's anything that you did not understand that requires further elaboration. Thank you.